So, you want to be a data scientist. But let me guess, you're probably feeling that completely overwhelming wave of where do I even start? You go online, and there are a million tutorials, 1,000 different libraries to learn, and literally no clear starting line. Well, welcome to this explainer. Today, we're laying out a definitive roadmap designed to pull you out of tutorial hell and get you actually building things. We're going to treat learning data science exactly like building a house. Because think about it, you can't just slap a roof on before you pour the foundation, right? We're taking a highly structured, learning-by-doing approach to take you from absolute zero to a complete end-to-end project.
Okay, let's dive into this. Here's our blueprint for today. First, the Python data science path. Second, the foundation, core Python. Third, prepping data, pandas and cleaning. Fourth, discovery, visuals and EDA. Fifth, a machine learning intro. And sixth, the final end-to-end project.
Section 1. The Python Data Science Path. Stop reading, start building. I want to reassure you right out of the gate, this exact roadmap will guide you sequentially through all the noise and give you a super clear, undeniable path forward. Look, this isn't some textbook you just passively read. It's an active quest. You actually have to conquer specific checkpoints, kind of like mini boss battles in a video game before you're allowed to move forward. Here's the visual roadmap of our construction project. We start with Step 1, Python Fundamentals. Then Step 2, Pandas. Step 3, Visualization. Step 4, Exploratory Data Analysis. And finally, Step 5, Machine Learning. The golden rule here is that each step strictly builds on the last one. Just like building a house, if you skip the framing and go straight to hanging the drywall, the whole thing is going to collapse. You have to resist the urge to skip ahead. Move at a pace that allows you to actually construct things. Section 2. The Foundation. Core Python. So the crucial point is, before you can do any of that fancy data modeling or AI stuff, you really have to get your hands dirty with the language that powers the entire process. You need your raw materials. Let's look at what actually makes up this foundation. These elements are the foundational bricks of your data science house. You absolutely need to intimately understand core types and built-ins, things like integers, strings, lists, and dictionaries. You've got to know how to build custom tools using functions, but what really holds all these bricks together? That's your mortar, control flow, and list comprehensions. Using if statements, for loops, and list comprehensions is how you direct the way data moves and transforms inside your code. Without that mortar, honestly, your data is just sitting there doing absolutely nothing. And here is your first mini-boss battle, the first mini checkpoint. You need to build a mini console-based data calculator. This basically means writing a script that takes user inputs, performs basic operations, and actually uses conditionals and loops to handle the logic. Why we do this? Well, because actually building this calculator proves you've internalized the Python syntax. It proves you haven't just, skimmed the documentation, but that you can actually wield the tools.
Section 3. Prepping data, pandas, and cleaning. All right, transitioning to the next phase. You've poured the foundation, now it's time to bring in the construction materials. But here's the thing about data science. Real-world data is practically never neat and tidy. It's incredibly messy. It's literally like a chaotic delivery of raw materials just dumped on a construction site that needs immediate sorting. To sort that absolute mess, we use Pandas. Pandas is simply the Python tool used to clean, reshape, and explore data in real-world scenarios. Before we even glance at the technical code, you really have to understand why Pandas exists. It exists because real data is full of missing values, crazy duplicates, and just terrible formatting. Pandas is your heavy machinery that organizes all that chaos into a structured format you can actually analyze. These specific functions right here, these are your exact scrubbing tools. For cleaning, you'll use commands like drop-NA to just throw out useless missing data, or fill-NA to plug the holes. For merging and reshaping, merge and pivot let you combine different data tables and view them from entirely new angles. And for grouping and aggregation, GroupBy is arguably your absolute most powerful tool. It lets you summarize millions of rows of data into neat, actionable categories in seconds.
Time for your next mini-boss. The Step 2 checkpoint challenges you to build a data cleaning script for a genuinely messy CSV file. But there's a catch here. You must add comments explaining every single step you take and why you're taking it. Because look, anyone can just copy and paste a drop now command from a tutorial, right? But forcing yourself to write out the why in plain English, that guarantees true, deep comprehension of the data cleaning process.
Section 4, Discovery, Visuals and Exploratory Data Analysis, or EDA.
Think of this as the inspection phase of our house build. We've laid the foundation, we've organized our materials, and now we need to step back and paint a picture of what we actually have to find the hidden stories inside the data. The official definition of exploratory data analysis is the phase where your analytical skills truly kick in to draw insights, detect trends, and prepare the data for modeling. The harsh reality of data science is that literally nobody, not your boss, not your clients, wants to look at raw tables of numbers. We have to become translators. We have to tell compelling visual stories that make those insights instantly obvious.
Now, what's really interesting about this slide is how we combine mathematical discovery with visual storytelling. On one hand, you're learning descriptive stats, finding the mean, the standard deviation, and calculating correlations using tools like Core. But simultaneously, you're using the matplot library to visualize those exact stats with scatterplots, histograms, and box plots. Visualizing the data directly empowers and accelerates your statistical discoveries. You can literally see the trends that the math is only hinting at.
So your Step 3 and 4 combined mini checkpoint is a massive milestone. You need to create a dashboard-style notebook, visualizing a public dataset using at least 4 different chart types, and then write an official EDA report summarizing your findings. At this point, you aren't just learning syntax anymore. You are acting exactly like a real data analyst reporting on real data.
Section 5, Prediction, Machine Learning Intro with Scikit-Learn. We've finally arrived at the final theoretical step. If building the house was our data preparation, machine learning is like installing the advanced smart home automation system. It's the predictive intelligence that brings the whole structure to life. For this, we use Scikit-Learn. It's the premier Python library used to model and predict data. But notice the absolute crucial caveat here. You only use Scikit-Learn once your cleaning and analytical skills are sharp. We absolutely never feed messy, unexplored data into a machine learning model. We only predict once the data is perfectly primed and ready. And this brilliantly illustrates exactly how we teach the computer to learn. Using Scikit-Learn, we split our data to test it using train_test_split. Then we can apply different models depending on our actual goal. If we want to predict a continuous number, like, say, a house price, we use regression. If we want to categorize something, like figuring out if an email is spam or not spam, we use classification. And if we just want the computer to find hidden groupings in the data completely on its own, we use clustering, like k-means. You are directly teaching the machine to find patterns.
Section 6, the final end-to-end project. Putting it all together. This is it, the ultimate boss battle. This is where you prove that you haven't just memorized definitions, but that you can execute the entire pipeline from start to finish. Let's move to this final checklist and see how everything builds into a final workflow. Step 1, load and clean the data. Step 2, visualize and run EDA. Step 3, train and test a model. Step 4, share on GitHub with explanations. Notice anything cool about that? It perfectly, beautifully mirrors the exact 5-step roadmap we just completed. It proves that every single piece of foundation you laid was entirely necessary to reach this final roof.
The entire philosophy of this source material basically boils down to this vital contrast right here. On the left, we have the wrong way, just completing tutorials and reading passively. Honestly, that just leads to the illusion of competence. But on the right, we have the active path, creating things, explaining your work to others, building a GitHub portfolio, maybe even writing a blog about your messy code. That active path is what takes you from merely learning a language to actually landing a real job in data science.
You now have the exact blueprint. You know the steps, you know the tools, and you know the exact mindset required. The only thing left to do is to open up your Python environment and face that very first mini-boss. So my final question for you is this. Are you ready to stop just learning and start actually building?